2 minus 6, 12 minus 12, 0, 0. And what's the next number?
0.
Is it 0? Is it? So what's the rule here? Yeah, so here you're multiplying by minus 3, and here you're multiplying by minus 2, and here you're multiplying by minus 1, and here you're multiplying by 0. So the next one will continue to be 0. Okay, so the next one was 1, 3, 12, 60, 360, 2520. Okay, so that's multiplying by 3, multiplying by 4. I see. Multiply 5, multiply 6, multiply 7, multiply 8. 21, 160? 20,160. Yes. Okay, let me give you one more before we go on to something else. Give you a hard one now. Now, real hard one. I'll be very impressed if anybody gets it. Okay, I'll give you a minute to try this one now. What happened to you? Why are you late?
I didn't sit down.
You were asleep? Good, huh? Any ideas what the rule is?
The rule is no rule.
Now that could be true, but I promise you there is a rule. Okay, want to see it? The rule? No, you think you can get it? I don't think so. Okay, let's see what is happening here. So, the reason I'm giving you this example is to show you that for a sequence, the rule can be anything. It doesn't have to be simply a maths rule like +1, +2, +3. The rule can be anything. So, what was the rule for the last example? This is what you do. You write down, firstly you just write down the number 1. This is the start of the sequence. And then to get the next numbers, we'll wait for that to go. Okay. To get the next numbers, you say what you have and write the numbers as you say it. Watch. I have 1, 1. Now I have 3 1s. Now I have 4 1s and 1 3. Yes? I told you wouldn't get it. And this is how you make the sequence. So now what have I got? 6 1s, 2 3s, and 1 4. Now what have I got? 1 2 3 4 5 6 7. So the next number is 8. 8 1 is the next one, yeah. That's okay. You're not supposed to. I'll just do it one more time for anybody who wants to get it. So you start, you write number 1, and tell me what I have. I have 1 1. Now what have I? I have 3 1s. Now what have I? 4 ones and 1 true.
Oh, I couldn't say one three.
You go from the smallest number to the biggest number as well. That's part of the rule. You say what you have from smallest to biggest, writing the numbers as you say it. Yeah, like that. Anyways, I just thought that was an interesting example because it shows you that the rule can be any rule. There's no restriction on what the rule is, okay? It can really be any rule. But obviously for maths, we will limit the rules to plus, minus, multiply and divide, obviously. Okay, so let's continue now. Have a look at what's next. So the best way to write a rule for a sequence is as a formula. So if you want to write the rule, you could write it, for example, like this. un equals 7 minus 2n. So if you write something like this, everything went okay with the exam?
It was going, yeah, okay. I was just waiting. I thought the class would be down in half, so I was waiting down there.
Ah, yes, you need to talk to the business students.
Just very quickly.
Yeah, go ahead before I start with this part then.
Thanks.
Business students, listen to Mark. Physics students, cover your ears.
Only one of them's covering their ears.
Okay.
Okay, I won't waste time. Business class. I've talked to you already during the week earlier about electing a class representative. Okay. So I'd like to do that in our business class on Monday. Okay, we'll organise it at some stage then. So if you want to think about it over the weekend, if you're interested,
There might be something
you
happening.
could add. This lady to be, she seems very interested.
There might be something happening behind you, you see.
Oh, right. Okay, you can vote for this lady or Stephen, but it'd probably be better to have one of your own.
Probably, yes.
Okay, alright, see you Monday. Enjoy the weekend, folks.
Wait, who am I putting my name behind? I'm supporting who? Who's the
Trump.
candidate? No, for class rep. Trump for class rep
Make
for business.
class great again.
Make business class great again. Okay, great. Okay, so as I was saying here, if you want to write a rule for a sequence, for example, you can write it like this. So this letter represents the name of the sequence. So we can call this the sequence U, for example. And the N represents what you call the term. So for example, U1 is the first term, U2 is the second term, and so on. In some high school books, you might have used the letter T. So if this looks more familiar, you could have written it like this. It's the same idea. Yeah. So for this example, the first term in this sequence will be 7 minus 2 times 1, which is 5. The second term will be 3. And one more will be 1. So this sequence is 5, 3, 1, etc. Okay? So this is most convenient if you can give your rule as a formula like this. Okay, so next now. Let's say, let's say I take this sequence here. As a small question, I want you just to practice. Tell me what the 100 term is. So just calculate that quickly for me. Minus 193, because it'll be 7 minus 200, so minus 193, yeah. Okay. Whoops. Okay, let me just give you another one just to practice now. So let's call this sequence V. So for the sequence V, the formula is 1 over n minus 1 factorial. Okay, so give me first, second, and third term. So if you can write that down.
First,
Second and third.
V is
Okay, what's the first term here? 1. And the second term? 1. And then the next term? 1 over 2. Yeah. So next now, there's different ways to write your formula for the sequence. So just before we jump into that, just to be super clear, what would you call this? Which term is this? This is the nth term. What's wrong, Sean? You look confused. You okay?
okay.
Okay. So if this we call the nth term, for example, and this one here, u1 is the first term, for example, what would this be? un plus 1. N plus 1 term. But in a simpler English, what does that represent compared to n? You could say that is the next term. Right? It makes sense. So then likewise, what would be un minus 1? The previous term. Do you understand the English here? And just one more. What would un plus 2 be? Yeah, but give me with good grammar, please. Better, but not this. After the next term. Yeah. Yeah. The term after the next term. Yeah. Okay, so you can actually use this to write a formula. Let's look at another example. So let's say we have something like, I tell you the first term is 5, and then I give you this formula. X n plus 1 equals 2xn. So how would you write this formula in words? Give it to me in words. The next term is, not quite twice the first term. The next term is twice the, or twice the present, if you want, present term, or, this term, the nth term if you prefer. Yeah? So using this formula, see if you can figure out the first 3 numbers. You actually already know the first one. I tell you this. What are the next 2? What is it? Is it not 50? 20, yeah. Next one more? 40. Yes, good. Okay. This sequence is a bit different to the previous sequence, because now, if I ask you what is the 100th term, now you realize, this isn't as easy as before, because what will you have to do? You'll have to first get the 99th term, after you get the 98th term, but after you get the 97th term. So, this type of formula is called something different to the other one. So just to give you the 2 types, one possibility is you say un equals, and you have a formula of n. Like for example, un equals, let's say, n squared. What is the terms here? 1, 4, 9, 16, for example. Or you can say un plus 1 is a formula of un. So the example here could be un plus 1 equals, let's say un squared, yeah. Now I have to tell you where to start here, so I also tell you to start at 2, for example. So if I start at 2, then the next term is 4, and 16, and 256, and etc. So you see, they're very different. Very, very different. We call this formula here recursive. And this one here, you can just call it direct. Which one is easier? Direct. Okay. So please note this as some more examples. Okay. Once you're ready, we'll have a look at some more examples. So, in a moment, I'm going to give you 3 sequences, and I want the first 6 terms. Got that? Can I? Fahad? Not yet? Okay, scrolling down. Yes, okay. So, let me give you 3 sequences. un plus 1 equals un, vn plus 1 equals 3 over 2 vn, and wn plus, actually you know what, let me write this last one a bit differently. Wn equals minus 7 plus 4 over vn minus 1. And here I tell you to start at minus 2. Here I tell you, let's see, to start at 1, and here I tell you to start at 8. Now just before you start, this is still the same. Here we have n and n plus 1. So this is still like present and next. Here, this is like present and this is previous, yeah. So then if this is present, then this one is still next. In other words, n minus 1 tells you what n is, just like n told you n plus 1. Okay, give me the first 6 terms for each, okay? 6 terms. Okay. Right, have we got the sequences done now? So, let's have a look firstly at U. What are the terms here? -2? And so on. So this sequence is just the number -2 repeated. That's all it is. Repeated. V. The first one is 3/2, and then next is 9/4, isn't it? 28. Okay, so is this right so far? 51? 81. Did you mix up 50 and 80? Okay, 81, and then the next one is 16. How far do I have to go? To 64, is it? Yeah. 243. Now I can do this one. 6, 7, 29. Yeah, don't believe in me. Okay. And W. Okay, so the first one is 8, and then we can open up the calculator, which I don't actually have. Anyways, next one. Huh? People have answers -2? Is it? -7, -13/2, is it? Yeah, -13/2. Okay, next. Do people not have this one yet? Do you need more time? Yeah, okay, take another minute. What are you talking about? This is right, isn't it?
W2 equals -7 plus 4 over...
Hang on. -7 plus 4/8 is -7 plus a half.
No,
Sorry, I said 4.
It's not... Yeah, W2 then. W2. W2 equals minus...
Hold on. W2
Yeah.
equals -7. Oh, sorry.
Yeah? Stop.
Oh, so interesting. Oh, come on, you knew that though.
Come on, you have to say everything.
Oh. Be reasonable, please. I had a very small lunch. Okay, recalculate. Okay, so what's the next one now after -13/2? No, but okay, so let's have a look here. -7 plus 4/13/2. Did you get this? -99/... 13. So then the next one would be minus 745 over 99. I need to do 2 more. But as you're doing this, you might realize something. Oh, why am I typing in the number again? Because if I just delete this and hit in answer. Oh no. No, no, no. Oh dear. Oh no. Oh, wait, back. Okay. Oh wait, no, I know what I'm doing wrong. There. So if I just type in answer, it should put the previous number into this. And I get this one next. But then you realize, I want to put this number in again. I already have answer in the formula, so I just have to press equals again. So, watch this. Guys, watch this carefully. If you want to do this quickly, what you could do, watch. First type in 8 and press enter. What is the answer? The answer is 8. Then type in minus 7 plus, minus 7 plus 4 over answer. What is the answer? It's 8. If I put 8 in here, what do I get? Minus 13 over 2. If I put minus 13 in, it's going to keep repeating. Watch. Yes, correct. What was the next one? Correct. You see? So you can... Okay. So I want to show you what's happening to this sequence in more detail for the next part. Oh, and I believe all calculators should be able to do that, as long as you have an answer key. I think everybody has an answer key. So, U, V, W. What was it? 1, 1 and 8 were the starting numbers? Yeah. So the formula for U is the next term is just equal to the last term. And for V, I think the next one is 3 over 2 times the last one. And for this one, what was it? 7? Was it 7? Minus 4 over the previous one. Oh, minus 7 and a plus, was it? Like that. So I should get this. So let me go up to term 100. Don't worry about those scary numbers. Okay, we'll stop here. So we'll go to term 50, which is this one actually. So sequence U is still, oh no, it wasn't, the first term was 2, was it? Yeah. Okay, totally different. Right, we'll go to the 50th term. So sequence U hasn't changed. It's still just the number 2. What has happened to sequence V though? What's happening to V? It's just increasing more and more. But something interesting has happened to sequence W. Yeah, so how would you describe this? What has W done? The additional extra, how would you describe what's happened to it? I mean, it's not getting smaller anymore. Yeah, so give me like a word that can perhaps describe this nicely. Do we know a word here? So, what the words you need to know are for the exam. This sequence here is moving to a limit. Wait, no, that's not the word. So the adjective to describe this, we call this a convergent sequence. Convergent. So up here I'll write the words. So this sequence we say is convergent because it's reaching a limit. Okay? This sequence is repeating. It's going 2, 2, 2. It's repeating. What's an adjective that means repeats? For something to repeat. And not, repeated is okay, but it's actually a more scientific word. Does anyone know it begins with a P? Oh, come on. I'm sure somebody knows it. Peter. Correct. This is the Peter sequence. Named after Peter, the original discoverer. Yes. Does anyone else know? Periodic. Persistent actually means constant, which actually would describe this particular one as well. But with periodic, it just means it's repeating. So just to be clear, periodic could also describe something like this. No, it's stuck. Yeah, here we go. So a sequence like this, 1, 2, 3, 1, 2, 3. This is also periodic because it's repeating. So does anybody know the name for the middle sequence? The antonym, the opposite of convergent is divergent. Yeah. Would you say sequence W converges quickly or converges slowly? Yeah. In fact, it's nearly reached its limit after how many terms? You know, by about the 4th or 5th, yeah. By around about 5 and 6, it's kind of almost there. Yeah. Now, just to be a bit technical here, if it has a limit, then we say it's convergent. If it has no limit, then we say it's divergent. So actually periodic would fit into which? Convergent or divergent? It depends. So for example, if it was a sequence like this, it's already at the limit. So in this case it'd be convergent. But if it's a sequence like this, does it reach a limit? No, so it's divergent. So if we have something which is periodic, if it's constant, then that means it's convergent. And if it repeats, that means it's divergent. Got that? Yeah? In the exam, what they sometimes like to ask you to do is what I just did. They give you 3 sequences and they ask you which is convergent, which is divergent, which is periodic. And the way you can tell is by calculating the first 6 terms should be enough. And you can actually do it pretty quickly on your calculator. Yeah? Okay, so let me give you some questions here to do. Ah, no, that's too many. 5 uses 4 as the, if you read 5, it says, decide in each sequence in the previous question if it's convergent, divergent, or periodic. So actually these two go together. Number 7 here, I think it's good if you do it, but it's not typical of the exam, but it's still good to try it. 1 to 6, this is definitely what you get in the exam. Well, number 1 is kind of nearly too easy for the exam. Okay, if you can start those for 5 minutes and I'll take the attendance.
Which will be again that page?
Which page? The had what? Thank you. Which page? Oh, do you want me to write it down for you? So you have 3, okay? Convergent. Divergent and periodic. Those 3 types, yeah. Oh, you want that page? No, types. Yeah?